Okay, so in this session we're looking at the equation of a line and sketching the straight line graph. So here we have equation of a line. The general form of the equation of a line is given by y equals mx plus c, where m is the gradient of the straight line and c is the y-intercept. Alright, so we have our graph here, x-axis, y-axis, origin. Alright, we have our line here, our graph is cutting the y-axis, right, at this point here. So this is the y-intercept, and the gradient here, remember the gradient is defined as the measure of the steepness of the slope of the line, right? In other words, how steep this line is, that's a gradient. Okay, so gradient of a straight line. There are four types. First one here being a positive gradient, right? Notice the line is sloping this way, right? This indicates a positive gradient. Next, the second one we have is a negative gradient. The line is sloping this direction here. Alright, so anytime you see the line sloping this direction here, or similar to this gradient here, it's a negative gradient. If it resembles this line here, it is a positive gradient. The third one is what we call a zero gradient, where we have a horizontal line. So any horizontal line in a graph will have zero gradient. Right? Any horizontal line in a graph, or any line parallel to the x-axis, alright, see this line is parallel to the x-axis as well, right, so that line will have zero gradient. And also any line parallel to the y-axis, or any line that's vertical, right, will have an infinite gradient. Alright, any vertical line in a graph will have an infinite gradient. Y-intercept. So the y-intercept of a graph is the point where the graph cuts the y-axis. Alright, so you have the y-axis here. Alright, the point that the graph cuts the y-axis is called the y-intercept. The y-intercept can be either positive or negative. So here, if the y-intercept is above the x-axis, as in this case, then it is positive. If the y-intercept is below the x-axis, this is our x-axis here, y-intercept is below the x-axis, then it will be negative. Alright, so here we are required to find the equation of a line based on the characteristics given. Alright, so clearly here we see that the y-intercept, it is above the x-axis, so it is positive. So it's going to be plus 5 here, and we are given that the gradient is negative 2. So the equation is going to be y is equal to mx plus c, where m is negative 2 and c is plus 5. Therefore, y is equal to minus 2x plus 5. Alright, so from the graph, it can be clearly seen that the gradient m is equal to negative 2, and the y-intercept c is equal to 5. Alright, recall that y is equal to mx plus c, therefore y is equal to negative 2 plus 5. Question, state a linear equation of the following graph. So we have a graph here, our y-axis, our x-axis, origin. We have a line that's sloped this way. Okay, and if you remember this, if a line or graph is sloping in this direction here, the gradient is going to be negative. So here we see that the gradient here is actually minus 3. We are given the gradient is negative 3, and the y-intercept lies below the x-axis, so it's negative. In this case, it is negative 5. So therefore, the equation of a line y equals mx plus c, y is equal to minus 3x minus 5. Y is equal to minus 3x plus minus 5. A plus and a minus is a minus. So we have y is equal to minus 3x minus 5. Okay, so next we're looking at sketching a straight line graph. For example, sketch a graph of y equals 3x minus 4. So clearly here, the 3, if we express in the form of y equals mx plus c, we see that m, the gradient, is 3, positive 3. Alright? And the y-intercept c is negative 4. Alright? So since the gradient m is equal to 3, positive 3, this means that the gradient is positive. Right? So it's going to look like this. Right? This is a positive gradient here. Also, the y-intercept c is equal to negative 4. This means that the graph cuts the y-axis below the x-axis. Right, so the y-intercept lies below the x-axis, so it's going to be negative here, and in this case it is negative 4. So we simply draw a line, right, this is the gradient, we draw in the same direction, cutting at negative 4. Right, and that's our sketch of the graph y equals 3x minus 4. Finding the equation of a line. So in addition to the general form, y equals mx plus c, the equation of a line may also be given by y minus y1 is equal to m into x minus x1. Okay? This equation is particularly useful when we are given, number one, the gradient and 1 point on a line, or two points on a line. Alright, so basically we can use this equation if you are given a gradient and 1 point on a line, or if you are given 2 points on a line, you can use this same equation here to find the equation of a line. Alright, example 1, find the equation of a line that passes through the point 3, 7 and has a gradient of 2. Alright, so here we are given 1 point on the line and we are given a gradient of 2. Alright, so given the point 3, 7, alright, and clearly you can see you can label 3, 7 here as x1, y1, where x1 is 3, y1 is 7, and we're given the gradient m is equal to 2. So it's a straightforward substitution into the equation of a line, y minus y1 is equal to m into x minus x1. Alright, where m is 2, alright, x1 is 3, and y1 is 7. So we have y minus 7 is equal to 2 into x minus 3. Y minus 7, we multiply the brackets. 2 by x is 2x, 2 by 3 is 6. So y minus 7 is equal to 2x minus 6. Bring across the negative 7 on the right hand side. Y equals 2x minus 6 plus 7. Therefore, y is equal to 2x minus 6 plus 7 will give us positive 1. So we have the equation of the line, y is equal to 2x plus 1, which is of the form y equals mx plus c, where the gradient m is positive 2, and the y-intercept is 1, positive 1. So if you had to sketch a graph, alright, we have our axes, x-axis, y-axis, origin. The graph cuts at c, which is positive 1, that's across here, and the gradient is positive, so it is going to be, the gradient is the shape of the line is going to be in this direction here. Alright, so this is our sketch of the graph y is equal to 2x plus 1. Example number 2. Find the equation of the line that passes through the points 11, 4 and negative 3, 2. So here we are given 2 points, right? The lies on a line, or a line passing through 2 points, right? So the first thing we need to do is to find the gradient. So we let one of the point be x1, y1, and the other point be x2, y2. So x1 is 11, y1 is 4, x2 is negative 3, y2 is positive 2. Now if you call the formula for the gradient of a line, right, m is equal to y2 minus y1 over x2 minus x1, right, which is change in y over the change in x. So substitute our values, y2 is going to be 2, right, minus y1, y1 is 4, all over x2, which is 3, negative 3, right, minus x1, which is 11. So we get the gradient is minus 2 over negative 2 over negative 14, which can be reduced to positive 1 over 7. Remember, negative and by negative is a positive, right? And 2 over 14 is 1 over 7. So always try to reduce our answers as lowest terms. So now that we have the gradient, right, and we have a point, we can find the equation of a line, right, by using the formula y minus y1 is equal to m into x minus x1. Alright, so substitute our values here. We know that m, the gradient, is positive 1/7. We know that x1 is 11. Alright, x1 is 11 here. Alright, and y1 is 4. Y1 here is 4. And the gradient here is 1/7. Okay, so making our substitution, we have y minus 4 is equal to 1/7 into x minus 11. Notice that this y here at the beginning, this remains the same. Right, we do not substitute for this y here. Alright, we only substitute for y1. Likewise, this x here remains the same, it remains in the equation itself. So we do not substitute for it, we only substitute for the x1. Alright, so we have y minus 4 is equal to, multiply the brackets, we have 1/7 x minus 11 by 1/7 is 11/7. And we make y the subject of the formula, so y is equal to 1/7 x minus 11/7. Bring across the minus 4 becomes plus 4. Alright, so y is equal to 1/7 x, and if we work this out, minus 11/7 or negative 11/7 plus 4, we can down the calculator, alright, if you wish, and you'll get here positive 17/7. Alright, so again, this is of the form y equals mx plus c, where m, the gradient, is 1/7, which is positive, so we have a positive gradient here. Alright, and the y-intercept is positive 17/7. Again, this is positive, so it's going to lie above the x-axis. Alright, we draw a line here, and this is our sketch of the graph.